Okay, so next we're going to look at the product rule. Okay, and this is a technique for differentiating if we have two functions multiplied together. So if you look at these ones I've written down, we've got x times by sine x, we've got x cubed times by ln x, we've got e to the x times by tan x, and we've got x times by the square root of x cubed minus 1. Okay, so if we were ever asked to differentiate any function that looked like this, first thing to realise is that we do have to use the product rule. Okay, and a really important thing is to realise that we will be using the product rule. If we got a question like this in the exam, they probably would not tell us to use the product rule. It would just say differentiate this, and we have to look at it and say, right, well, there's two functions times together, I'm going to use the product rule. A common mistake that people make when they first start this topic is if you're just asked to differentiate this function, you just differentiate everything. So we say, well, x differentiates to 1, sine x differentiates to cos. So you think the answer is cos, but that is definitely not the correct answer. Okay. Now, what the product rule looks like, you've got it in the booklet using f of x and g of x notation. You may also see it written like this. So if y is equal to u times by v, so we identify that we've got two functions of x which are being multiplied together, then we say dy by dx would equal u dv by dx plus v du by dx. We don't get this in the formula booklet, so we do have to remember this, but we'll do enough of it this year that you'll soon do it really quickly without much problem at all. Okay, let's try a few quick examples. Okay, so if I said, remember this notation means differentiate with respect to x. So if I wanted to differentiate with respect to x, x squared e to the 3x, obviously we'd look at that and say, right, well, we've got two functions multiplied together. So I'll say u equals x squared and v equals e to the 3x. And once we've done that, all that we do is if we look at the product rule itself, okay, so we want to apply this rule for differentiating, and we're going to do u times by dv plus v times by du. Okay, so if I know that u is equal to x squared, I'll just quickly differentiate that with respect to x. So du by dx would equal 2x. If I know v is equal to e to the 3x, then dv by dx would equal 3 e to the 3x. And you might want to remember like this cross pattern just as you're getting used to this. So it's u times by dv and v times by du. Okay, so the answer for this, the derivative of this, would be u times by dv. Now, when we start doing this, we actually end up multiplying a lot of functions together. Initially, while you're getting used to this, it's a really good idea to just write them both in brackets. So we do u times by dv. By writing it like this, it lets the examiner know that, look, I'm multiplying these two things together. You get your method mark for doing your product rule, and then on the next line you can tidy it up. If you do too much in one go, you lose your method mark. You'll also lose your answer mark because you've probably made a mistake by trying to do too much. And then we've got v times by du, which would be e to the 3x times by 2x. So tidying this up. Always put the number at the front. So we've got 3. Then the algebra comes next. X squared. Put the exponential at the end. E to the 3x plus 2x e to the 3x. Okay. You will probably, if you get a question like this, want to go a little bit further. Like that's the answer, you've differentiated it. But thinking about what comes next, like stationary points or tangents, normals, a really useful thing is to take the exponential out. Because then if you are going to think about a stationary point, you actually get two things times together, and you can think about them both separately. And we'll see some examples like that a bit later. Okay, so if we look at the booklet, example 1 says differentiate x cubed sine x with respect to x. I'm just going to write WRT for short. And obviously it doesn't mention product rule, but we look at it and say, right, well, we've got two separate functions which are being multiplied together. So u would equal x cubed, v would equal sine x, du by dx would equal 3x squared, dv by dx would equal cos x. So therefore my answer would equal u times by dv, which I'm going to write as x cubed cos x, plus u times by dv plus v times by du. So v times by du, we're doing sine x times by 3x squared. I'm going to automatically write that with the number at the front, so I'm going to write it as 3x squared sine x. Okay, think about it, if I wrote it the other way around, if I wrote it as v times by du, so if I wrote it as sine x 3x squared, like a lot of people would think, oh, I'll just multiply all that stuff together, but that x there is stuck inside the sine function, and like to avoid that mistake, we just put the number at the front, the algebra next, and then put the trig at the end. You never really want to have it written in this way, where you've got your algebra multiplied by your trig function and your trig function at the front. Okay, so we'll leave it like this. I suppose if we were going to do anything with this, they've both got a common factor of x squared, so we could take a factor of x squared out, but I'm going to leave it like that for now. Okay, next example says differentiate ln m sine m with respect to m. Okay, so don't let the fact that it's an m freak you out, it's just the same as if it was an x. Okay, we're differentiating a function of m with respect to m. Okay, so u would equal ln of m, v would equal sine of m, du by dm. Remember, when we differentiate a log, it becomes a fraction. The function inside is m, so we get m on the bottom, and the derivative of m, which is just 1. Okay, don't forget, m is our variable. If you differentiate x with respect to x, you get 1. If you differentiate m with respect to m, you get 1. Okay, dv by dm, sine of m goes to cos of m. Don't do anything weird with this. Like, I've seen people sometimes get freaked out by the fact that it's an m. Okay, sine of x goes to cos of x, sine of m goes to cos of m. If you do want to multiply the front by anything at all, thinking about what the ones we were doing earlier, the coefficient of m is 1. So if you differentiate m, you get 1. So you're multiplying the front by 1. Do not multiply the front by m. Okay, so the answer would be u times by dv. It's a bit of an unusual one, this. I've got a log multiplied by a trig function. You could write it either way around, to be honest. It might be better if we just use a bracket. I'm going to write it as ln m cos. By putting a bracket around that, it makes it clear that that m there is inside the log function, and we're not going to start like multiplying m and cos together. We can't do that. And then we've got v times by du, so that's 1 over m sine of m. The next thing to look at after the product rule is something called the quotient rule. Okay, now don't get freaked out by this notation here. This is just basically saying if I want to differentiate a function which has got a fraction, so we've got like a function on the top and a function on the bottom. The product rule was when we were multiplying two functions together. The quotient rule is for when you've got a fraction, so some function of x on the top, some function of x on the bottom. This notation here is what we get given in our formula booklet. So if you can't remember this, hopefully you will remember it because we'll do a lot of it, but if you're ever struggling in the exam to remember this, you can look and it'll look like this in the formula booklet. I usually use this version, which you don't get in the booklet. So instead of like f and g, I just call the top part u and I call the bottom part v. And then it's v times by du, which is the same as g times by f dash, but get used to using either version. With that one there, you'll get in the formula booklet. Okay, let's try a quick example. So if I wanted to differentiate with respect to x, let's say we had e to the 2x, and that was divided by x squared minus 1. So clearly we've got a fraction where there's a function on the top and there's a function on the bottom. Okay, so if we want to get used to using this notation, I would just say, well, f of x is e to the 2x, and g of x is x squared minus 1. Okay, so all we're doing at the moment is we're looking at our fraction. The top part we're calling f, the bottom part we're calling g. Okay, and then looking at the formula, we need to figure out what f dash is, and we need to figure out what g dash is. So f dash of x would be 2 e to the 2x, g dash of x would be 2x. Okay, I'm going to be careful how I set this one out now because I've got to multiply a lot of stuff together looking at this formula. Okay, so it's f dash times by g, which is f dash times by g. So I've got 2e to the 2x multiplied by g, which I will definitely need to put in a bracket because that's two separate terms, minus f times by g dash, which would be e to the 2x times by 2x, all divided by x squared minus 1 squared, because it's g squared, isn't it? Okay, really tempting to, when you see something like this, first thing people do is they go, oh, there's a bracket squared, let's just expand it out. Just hang fire for a minute, like don't square that bracket, leave it as it is. It's a factorised bracket, it's probably easier to work with it like this. All we do need to do really is just tidy up what's on top of the fraction. Okay, so we could take a fact, actually I've got e to the 2x, every term, if I times this out, every term would have an e to the 2x. I'm just going to take that out and see what I've got left. So there's 2x squared. 2 times by minus 1 would be minus 2. Minus 2x. And then that's all divided by x squared minus 1 squared. I could leave it like that. I suppose one thing I could potentially do is take a factor of 2 out and write it as 2 e to the 2x, which would leave me with x squared minus x minus 1. But I think I'll leave it like that for now. Okay, so if you look at the booklet, the first example on the quotient rule, it's actually a bit of a sneaky on this because it's actually getting straight into doing it in terms of y. I mean, it's not a big deal, but normally we probably do a few more with x first. This says differentiate with respect to y using the quotient rule. Okay, so clearly we've got a function on the top, a function on the bottom. I should, if I'm going to be technically correct, write f of y. So the function on the top is cos y. The function on the bottom, which we normally call f of x and g of x, is f of y, and g of y, which would be e to the y. So if I want to find my derivative, if I differentiate cos of y, it goes to minus sine of y. And if I differentiate with respect to y, e to the y, well I know e to the x when I differentiate stays as e to the x. So e to the y when I differentiate stays as e to the y. Okay. Again, if you're really tempted to start multiplying stuff at the front, the derivative is 1, so you're multiplying the front by 1. You wouldn't notice. Okay. So this will look like we do f dash times by g. So it's going to be minus f dash times by g. I'm going to write it as minus e to the y sine y minus f times by g dash, which is this times by this. I'm going to write it as e to the y cos y. all divided by g squared, which is e to the y squared. Okay, so we've got a little bit of tidying up to do here. You notice that within this fraction, there are three terms. Like when I look at that, I just mathematically, I just visualize that as there's one term, there's two terms, and there's three terms. And if you do want to cancel anything down from a fraction, very important that if you're going to cancel anything, all three terms have to share a common factor. Okay, let's do a little side question where people make mistakes. So say if I would have had x squared minus 1 over x to the 3. A mistake sometimes people make here is what they see that they will, on top of my fraction I've got an x squared, on the bottom of my fraction I've got an x cubed, and they cancel x squared and x cubed, and then they just write that as 1 minus 1 over x. And it's just complete nonsense, isn't it? Like you can't cancel an x squared from this and an x squared from this because there's another term there. Okay, so just be careful. We do have three terms and they all share a common factor. So I am allowed to cancel this one down. Okay, if I cancel an e to the y from this and from this, and if it's an e to the y squared, if I cancel one of the e to the y's, I'm just left with e to the y. So we could write it as minus sine y minus cos y all divided by e to the y. So 6b actually says same question but differentiate using the product rule. You might be thinking, why would they use the product rule? Like clearly we've got a fraction, but sometimes it might be easier to use the product rule instead of the quotient rule. Because if you look at this function, it's cos y divided by e to the y. We could also write that as two functions multiplied together. Like if it's e to the y on the bottom, that's the same as cos y times by e to the minus y. And we can see that now we've got two functions which are being multiplied together. Okay, so if we write it as u equals cos y, v equals e to the minus y, du by dy would be minus sine of y. Don't forget, whenever you differentiate in trig functions, we know that cos goes to minus sine. Okay, dv by dy. Be careful with this one. If we differentiate the exponential, the power stays the same, so it'll be minus y, but we have to multiply the front by the derivative. So if we differentiate this, we get minus 1. Okay, so then the answer would be product rule. We do u times by dv, so we're going to do this one times by this one. So u times by dv, I'm going to write it as minus e to the minus y cos y, and then it's plus v times by du, which is e to the minus y, multiplied by minus sine of y. So again, we could look at this, actually we've both got a factor of e to the minus y. You could take a minus 1 out as well if you wanted to, but I'm not going to. You'll see why in a second. So it's minus cos y minus sine y. And if you look at the answer that we got earlier, using the quotient rule, we've actually got the same answer. It might just look a little bit different. Like if you've got e to the minus y, that's the same as having minus cos y minus sine y all divided by e to the y. And we should get the same answer no matter what technique we use. Like as long as we apply either method correctly, we should get an equivalent answer. Okay, we've got one more technique to look at, which is called the chain rule. You might want to have a go before we do the chain rule. If you look at Oh, sorry, there's actually one other quotient rule question, example 7. Have a look at that one. You should be able to figure that one out from the working out in the booklet. So try example 7, and then the next video I'll introduce the chain rule. If you wanted to practice a couple of questions though, you could try exercise 3, have a go at A and B, and then the next video we'll look at will be about the chain rule. Okay.